Hello, everybody, and welcome. It is I, Bones Malone, back at it again with another chemistry study guide on different topics in the chem lab. Today, we'll be doing how to write a lab report. So, today, I'll be showing you guys the basic rundown on how to write a lab report in a class like chemical analysis, where you'll be basically analyzing different substances to determine the concentration, the amount of mass of a specific substance, and basically sometimes you'll be performing a statistical analysis of those different substances to get different data. Basically, practice for real life applications in the lab. One example I used in the last video is if you are, for example, in the field and tasked with analyzing a water source to find out how much chloride is in the water, you might perform something like gravimetric analysis and then statistically analyze that data to determine how much chloride's in the water sample. So today we're going to be showing you guys how to write a lab report like I previously mentioned, and today we're doing the gravimetric chloride analysis. So like the previous practice problem in the previous video, we did a little practice problem on how to find the molarity of that, but today we're going to be showing how to write a basic lab report using this. So essentially we're going to ignore these first two parts right here. Basically the sample I analyzed was unknown C. They were all labeled A through C. And basically we're gonna start by looking at the purpose of the lab. Now, first you want to start out by doing this format. You want your name up here, you want the date, the title of the lab, your unknown sample label if you're given different samples, for example, in a classroom, and then eventually you're going to calculate your average, which is your mean, plus or minus your standard deviation. Now, the introduction is essentially the purpose of the lab, so it's about 2 to 3 sentences, a little bit less than a paragraph, what the purpose of the lab is. So today, the purpose of this lab was to precipitate Cl out of solution and perform a gravimetric analysis of the precipitate to determine the amount of Cl in the original sample. Performing this analysis will also provide the mean, standard deviation, and the confidence level. So in a couple short sentences, I basically described the purpose of the lab. So today, we're going to be performing a gravimetric analysis to precipitate Cl out of a solution. So basically we're going to take our sample, we're going to turn it into a solution by dissolving it, and then we're going to precipitate that out. So we started with an unknown sample. We didn't know what it was. So and next we move on to method, technique, chemical reactions. So this is the second part of your standard lab report that you're going to want to fill out. In this section, you basically want to name the methods or techniques and write the chemical reaction depending on which applies. So in this case, we did a quantitative transfer, crucible vacuum filtration, gravimetric analysis, analytical weighing. So we're going to break these down. Quantitative transfers, basically transferring your solution, different parts of the lab to different glassware, like your flask and things. A crucible vacuum filtration. So essentially we used a crucible with fiberglass paper at the bottom to perform a vacuum filtration, which uses the vacuum from a sink that's created in this flask to essentially pull out all of the liquid or solution out of a precipitate or the powder that's formed at the end of your chemical reaction. So basically you're left with your powder that you can use after it's dried to weigh it and obtain the mass of what you're looking for. So in this case, AgCl. So after we perform the chemical reaction, we're going to be left with AgCl, and since we're looking for Cl, and that's the substance we'll be analyzing, we'll be left with a powder of AgCl or precipitate, essentially a solid that we can weigh. So we're going to be using crucible vacuum filtration to essentially filter that and leave it as a dry powder so we can weigh it later for analysis. And then gravimetric analysis, I explained that in my previous video, and then analytical weighing, which is basically using an analytical balance to determine the mass of your unknown sample before you start the lab, and then the mass of your precipitate, which is AgCl, that you'll be measuring at the end. So after that, you're going to want to move on to the experimental procedure. Now basically in this section, you're going to want to lay out exactly step by step what you did for the entire lab. So you want to break it down into sections, and you want to refer into the past tense, and you don't want to use words like I did, we did, my group did, me and my colleagues did, my colleagues and I did. No, you explain what happened in the past tense without using those that specific language. So, for example, we took we don't say we. 3 goose crucibles were cleaned and heated to 120 degrees Celsius for 45 minutes in a 600 milliliter beaker, along with the unknown chloride sample. So basically, how I started the lab to perform this gravimetric analysis is I took 3 goose crucibles, which essentially hold the precipitate later on to perform the vacuum filtration, and they're made out of like a ceramic-like material. I put them in a 600 milliliter beaker, and I place them in the oven in the lab to get them to 120 degrees Celsius to basically and essentially remove any moisture. So look at this language. I didn't say I put, and I didn't say that we decided to perform this in order to. I basically just said exactly what happened in the past tense. I used words like were, seconds after that. A wash solution was prepared by adding 32 drops of concentrated nitric acid, and 400 milliliters of water. And again, I didn't say I created a wash solution. I said a wash solution was, in the past tense, prepared by adding 32 drops of concentrated nitric acid. So after we have explained the procedure step by step from the beginning of our lab to the end of the lab, it's also important that you mention specifically what you used, what reagents, what glassware, units. I put Celsius, it's not Fahrenheit, milliliters, not liters, grams of specifically everything, because you want to be as methodical and accurate as possible in your lab report. Because essentially, for this lab report, it's done in a classroom setting, so it's not that important, but in an actual field, it'd be extremely important to be as detailed as possible for others, because the purpose of this lab report would be to give to other individuals who would want to retest and confirm your findings, and to show how important they are. So next, you want to specifically state what reagents were used. So essentially this is which chemicals are used in the lab in a basic sense. I didn't include water even though water was used, so as I stated before, we used silver nitrate, like I mentioned in the previous video for that practice problem, but this is the real life example. Silver nitrate, concentrated nitric acid, an unknown Cl containing sample. So this is essentially our unknown C. It was a little vial filled with a powder, and all we know is it's an unknown sample containing chloride. And that's what we're going to be finding in this lab particularly, but that doesn't really matter because we're showing you how to write a lab report, not necessarily how to perform the gravimetric analysis of a chloride sample. So for this step, reagents, essentially what chemicals you used in the lab. I didn't include water, but water was also used. Instrumentation glassware. So in this step, we want to name the instruments, glassware sizes that should be included and specified in your instructions. So if you provided instructions in the classroom on how to perform this lab, you essentially want to label and mention all the glassware you used and the instruments. We use an analytical balance for weighing, so that way we could measure how many grams of the solid substances we had. We used a 600 milliliter beaker, as mentioned in the procedure, 350 milliliter beakers, a graduated cylinder, 3 crucibles, vacuum filtration apparatus, disposable pipettes, 400 milliliter beaker, thermometer, stirring rod, hot plate. So basically, you got your hot plate, analytical balance. Those are the instruments you use on the glassware, beakers, crucibles, filtration apparatus, things like that. So next, you want to, now this is an extremely important section, arguably one of the most important sections. You want to mention your raw data. So this is basically your tabulated results or graphed results. The data has to include headers and titles. So we have your title, we have headers, and then we have one paragraph explanation. Could be a little bit longer, could be a little bit shorter, essentially explaining what the graph is, or the table. So in this case, we have masses measured to find chloride concentration of a sample. So we have what we weighed. So we took our weigh boat, which is essentially a container that you use to weigh out a sample in the lab. So we have our weigh boat, we measured that, and then we put our unknown sample in. So in this case, our unknown chloride containing sample, unknown C. And then, so we weigh the weigh boat without any substance in it. we zero it out on the analytical balance, and then we place our sample in, and then we weigh that, and then, I'm sorry, you don't zero it out. In some cases, you could do that. You would put the weigh boat on, zero it out, place the substance on, and then you could use that. But for more accuracy, or closer accuracy, you can you weigh the weigh boat completely empty. You write down that mass. This is in grams, by the way. You have to specify what units. Always specify units. And then you measure the mass of the weigh boat with the sample. So you essentially put your powder in, or your sample in, and then you write down that, and then you take the difference between the mass of the weigh boat with the sample, and then the mass of the empty weigh boat, and then the difference will obviously provide you with the mass of the sample. Now, so essentially, and you also, this is extremely important for the purpose of lab, in order to be precise, which is essentially precision, I would have to describe that as repeatability almost, if I could put it in simple terms. So essentially, we repeated this 3 times. So as you can see, this is essentially like my target mass was around 0.3 grams of my sample. So I weighed as close as I could get to 0.3 grams every time. So you know, measure the weigh boat, add the substance in, measure that, take the difference, and then get as close as I can to 0.3 grams. And so I did this 3 times, so that way I have 3 different trials to prove that I'm accurately obtaining the same results, in order to essentially prove, like I said before, repeatability. That's the goal of a lot of sciences, is to show a relationship between findings. You don't just do it once. If you do it once, you know, there's an introduction to error. It could have just been random. There could have been other factors. But if you repeat these results, it proves that they are precise and they're hopefully accurate to what the true value should be. So then we did the same thing for the crucible. After we performed our chemical reaction and formed silver chloride, we measured the mass of the empty crucible, then measured the crucible with the mass in it, and then we found our mass of precipitate, which is our mass of AgCl. Once again, get your units, and then we have mass of CO. And now mass of CO, I will show you how I receive these calculations in a moment, and then percent of Cl. So this is essentially the percent of chloride in solution in the original sample, our unknown sample, but that's not important, because once again, we're showing you how to write a lab report. We're not showing you how to do this particular lab. So in this case, basically, we have our mass of our unknown sample. That's what we found. We found the mass of the precipitate, which is what we formed at the end of the lab, and then we have the mass of what we're looking for and the percentage of what we're looking for in that original unknown sample. So remember, we have units, we have a title for the graph, we have labels, we also did important calculations for gravimetric analysis, such as standard deviation, mean, and range, which we will use to perform Q-tests, which is essentially a mathematical calculation to discover whether or not any of these data points are outliers and should be used in the rest of the calculation. So for this next section, I have described in one paragraph, very simply, exactly what's in my graph and why it's useful. So we said this data was collected throughout the lab in order to form the foundation of the gravimetric analysis. The different masses were used to calculate the weight of the sample and the weight of the precipitate formed in the lab. This data was used to find the concentration of chloride within each sample and to find statistical data such as the mean, the Q-test, the standard deviation, the confidence limit. So basically, in summation, the purpose of this graph is to tabulate the results that I found in order to find the mean, the standard deviation, the confidence limit, and the amount of chloride in my original sample. So next, I have a graph right here. Well, it's not a graph, sorry. I have a table right here, and this table is essentially the same thing as this table, except it's done in Google Sheets or Excel. Because the math can be done automatically instead of having to input the computations and calculations in a calculator specifically. It's just a lot easier to use Excel, so I put my picture here, even though it's the same stuff essentially as what's here. I took the picture of it because, once again, we want to prove repeatability, precision, and accuracy. We want to make sure all of our results are clearly placed in our lab report so that way anyone looking at the lab report can see exactly step by step what we did. So, basically, I did this in Google Sheets, so we have the mass of the chloride sample, and then this is, I did a calculation for a Q-test, and then standard deviation, because the software does that all automatically, so I did that instead of doing it in the calculator. And then this next part is also extremely important for explaining how you got your results. Now, it's also important to mention that here, if the lab required it, or if my professor or place of business required it, I would have a graph that also demonstrated this data that's in a table form, but I did not do that for the purpose of this assignment in the lab. So next up, you have to show your sample calculations, which is essentially several calculations done to show how you got these values and the values in this table. So I need to show exactly, even though it's already assumed if you look, you can kind of tell by looking that this is clearly the difference between this value and this value, to show that I labeled it first sample 1% concentration of Cl. So we have sample 1, and then the percent concentration of Cl. How did I get that value? I basically multiplied the grams of the precipitate and divided it by the grams of our unknown sample originally times the molar mass of Cl over the molar mass of silver chloride times 100 gave me my percent concentration. So basically what I did was I showed exactly how on my previous table I got this value, and I showed my work. And once again, you always want to show your work so that way anybody who's above you or reviewing your work can tell you what you might have done wrong or ask you any questions on why you've decided to make certain decisions. So now we have the same thing for all these, how I got the suspect and the Q-test value, confidence limit, how I got the mass of the precipitate, and then next up, after you've shown all of your sample calculations, you want to write a discussion. So it's basically a couple paragraphs where you reflect on your results and speculate. And you do that by showing any disagreements in the data, why your results may be reasonable or unreasonable, how the final results compare to the theoretical results, possible errors that could occur, possible mistakes you might have made in the lab that can affect your data, how other students or other individuals who performed the same lab performed it, and how they might have done it similar or different than you, and compare your results. So essentially in the discussion, I started out by saying the mass of the sample and precipitate were both measured by taking differences. Oh, there's a typo here, sorry about that. Of the weighing instrument with the substance and without it. With these numbers as shown in the chart, the amount of Cl in grams formed, the precipitated AgCl was calculated by dividing. So essentially what I did here is I'm explaining how I got my results. So I'm basically in the discussion explaining that I used the values I showed in my sample calculations. I explained that basically I showed my work in the sample calculations, and in the discussion I say in words, I showed my work here and the results ended up here on the table. So you explain how you got your values, any issues that could have happened, exactly how these values impacted the rest of your data. So if you had, let's say, 58.94% Cl in sample 1, and around that value in sample 2 and sample 3, in the discussion you want to talk about what that means. So in summation, you got around 57%. You can assume with reasonable certainty based on the preciseness of your lab results that around 57%, you basically take the average of these three, around 57% of your unknown sample C or unknown sample is comprised of chloride. So you basically want to talk about that there. So you want to explain all your results, explain what they mean, any problems that could have occurred. So after that, you want to explain why all that data is important and how that impacts your results. And then you can do a little conclusion on how and why it's important to perform these sort of procedures in the lab, such as gravimetric analysis. Like, for example, I said in conclusion, gravimetric analysis can be used to identify the concentration and the amount of particular substances in an unknown table. So basically explain why gravimetric analysis is important. And then you have your references. You always want to cite any things you use. So in this case, I used my textbook and our lab manual that were assigned. And then, as an added bonus, I have a picture of my work drawn out on a post-it note and all of my examples or all of my lab results physically written on paper. So basically, in summation or review, you have your name, the date, the title of your lab that you're performing, your mean plus your standard deviation, which is optional in a lot of cases. Well, it's not optional in this case, however, I mean optional as in all of your lab reports aren't necessarily going to require these values to be at the top. Your introduction, which is the purpose of the lab, where you introduce the purpose and the reason you're performing the lab, the techniques, the reactions, and the methodology used. So, chemical reaction that occurs during the lab, what you did, experimental procedure, exactly what you did step by step, written in the third person without saying I, essentially written without the first person in the past tense, without using I, we, reagents, chemicals used, basically what chemicals used in the lab, instruments and glassware, what you used to put the chemicals in, so beakers, what you weighted on, which is the balance, raw data, a table of all your values that you found, a description of the table with units, title, etc., pictures of exactly where that table came from if you used a separate software, calculations and how you got the values of that table, the discussion explaining exactly how you got all your data, how that data impacts your results, what the impact of your results means in the grand scheme of the lab, any problems that could have occurred, and then why performing said lab is important or said method is important, references of where you got your information, which is basically citing your sources, similar to how you would do for an English class, and then a picture of your lab notebook or your handwritten calculations and data points that you got during the lab. I hope you guys enjoyed and learned something. If you have any questions, please comment below. I hope I can help you, and I hope you learned a little bit, or this took a little bit of anxiety off of you on how to write a lab report in the classroom. Thank you, and have a good day.